Hi, everybody. In this video, we're going to continue with percents and actually start working with how to solve percents. So in this video, we're going to focus really on the general setup. And then in further videos, we'll actually get into the applications. All right, so we are going to learn how to solve percent problems using equations. So before we get into this, I do want to make a quick note here that there are actually two ways to solve percent problems. The first way is using equations. And the second way is using proportions, which we saw already. Now, both of these are valid methods and ways to solve percent problems. I'm going to focus in this video and in the next few videos on how to solve using equations. I think it'll be easier for us to focus on one strategy rather than trying to do two strategies for every single problem. However, if you are interested in solving percent problems with proportions instead, just reach out to me and I can give you some resources on that and point you in the direction of how to go ahead and do that. And so that's something you may have seen in earlier classes. So I do find that using the proportion tends to be taught now a lot more in middle school and high school. So if you have recently gone through a math class, they may be more familiar to you. And it sort of uses the idea of is over of equals the percent over 100, or I've also seen it as part over total equals percent over 100. So that's the basic setup for how to solve percent problems using equations. It works very nicely for the pretty straightforward equations. It gets a little bit more complicated when we start doing things like percent increase and percent decrease, but it is possible to do it. So again, like I said, I'm going to focus on how to use equations in the next few videos. I think it'll be easier for us to just streamline our process and focus on one strategy rather than two very different strategies. But if you know how to solve equations using proportions, or if you want to learn more, that's totally fine. It's another valid way to solve, and some students do like it. So if you want more information about this, just reach out to me. I'm happy to point you in the right direction there. Like I said, I'm gonna stick with equations. I do find that most students end up gravitating towards the equation piece eventually anyway. So that's where I'm gonna focus. Okay, so when we're writing our equations, we are going to use some keywords. And we've seen all these keywords already, but I'm going to just kind of rewrite the most important ones for percents. So the first keyword that we see here particularly is that word of. And of is used a lot, as I mentioned already, for multiplication, particularly with things that are parts of a whole. So we use of a lot with decimals, with fractions, and with percents. So we'll say something like 40% of a number, or we'll say 3/4 of the total. So when we have parts of a whole, we tend to use that word of a lot, and it represents multiplication. Another word we're going to use here a lot is the word is, which I think we all know means equals. Okay, so that's your equal symbol there. And then for our basic problems, you're going to sort of have a what idea. I'm just going to put a question mark because it may not be the exact word what, but it could be. And this is what we're trying to find. So this represents the unknown, or what we need to find, like our goal of the problem. And what you can do here is you can use a variable. Now, typically for us, just to be consistent, I'm probably going to use X most of the time, but you can use another variable. A lot of times I'll see the variable N there. N is often used to represent number. So it doesn't have to be X. Any variable is fine, but I'm going to just probably stick with X for most of our examples. Okay, so before we get into solving, let's just practice translating into an equation. And there's one more thing I want to note here for certain examples once we get to it. So it's a very important note. To use a percent in an equation or with a calculation, so if you're multiplying with the percent or you end up doing something different with it, we typically must change it to the decimal or fraction form. So for instance, let's say I was working with the value of 60%. Then I would either change it to the decimal form. So remember, for the decimal form, we ended up multiplying it by 0.01 if you're using decimals. So you're moving that decimal point 2 spots to the left. And you would use 0.60 or 0.6. Or if you want to use the fraction form, you're taking that 60 and you're multiplying it also by 100th, but in the fraction version. So you have 60 over 100 here. I can cancel out a pair of zeros right away. That's actually dividing by 10. And then I can keep simplifying by dividing this by 2. See if I can fit it in here. And we have 3/5. So when we're working with percents and we're setting up our equations, if you are given the percent, you do need to change it to the decimal form or to the fraction form in your equation. We don't usually leave the percent symbols there. And you'll notice here, if you are a proportion person, then we're actually using that fraction form. So you're still doing it in proportions, it's set up a little bit differently. But again, that percent is being changed into the fraction form because you're putting it over 100. Now, I will say most students tend to prefer the decimal version, and that's what we usually see a lot more in equations anyway. So for our purposes, again, most of the time, I'm going to stick with that decimal version instead, but you could also change it to the fraction version if you prefer that. So let's go back to our example here. Right under here. So it can be A. So 6 is what percent of 50? Now here, 6 and 50 are not a percent, so I don't have to worry about changing anything over. The only thing we change over is if we have an actual percent. But I am going to use my keywords. So I see this word is here, which represents equals. I see that word of, which represents multiplication. And then I also see my question. So my question here is what percent? So in this case, we are trying to find the percent here. That's what we're looking for. So let's go ahead and set this up then. So I have 6, is means equals. Now what percent? I don't know the percent, so I'm going to use an X there. Of means multiply, and then 50. So technically that's our setup. Now, usually if we're multiplying a variable to a number, we like to put the number first, just a little bit easier to read and work with. So I'm going to switch that order there, and I can do that because of the commutative property. And I'm going to write this as 6 equals 50x. But actually both of these would be correct. It doesn't matter. All right, let's do another one. So we're just going to do a bunch of translate ones to start. Okay. So 1.5 is 40% of what number? So here, again, I see those. Let me get my colored pens out here. So keywords, so I see that word is equals. I see of, which is multiplication. I don't know what number it is, so we're going to use an X there. So I'm going to start by initially writing this. So it's going to be 1.5 is 40% of what number is X. Now, as I said before, this is a good starting point, but when we're actually going to solve equations, we never leave that percent there. So I do need to change it over. And I'm going to use the decimal version. You can also use the fraction version. I just find most students tend to like the decimal, and that tends to be more consistent with videos that you may be watching online or things you may be reading in your text as well. So I'm going to change this to the decimal version. So I take that 40 and I multiply it by 1/100th, right? Which in our case means you're going to move that decimal point 2 spots to the left. Now, if you can do some of this in your head, then that's fine with me. You don't have to always write out every little detail as long as you can follow your work and I can follow your work. But I'm just going to write that out just so we can see all the steps. So I have 0.4 times x, or just 0.4x. So 1.5 equals 0.4x, or 1.5 equals 4/10 times x. Okay. What number is 10% of 5 thousandths? There we go. All right, so my keywords here, I see is, there's my equals. I see of, which is multiplication. Here is my question, right? What number? And I'm going to start filling it in. So I have x equals 10% times 0.005, or 5 thousandths. And just like before, I am going to convert that 10% over. So we're technically multiplying by 1/100th, which means you're moving that decimal point 2 spots to the left here. Now, again, as you get more comfortable, sometimes students will just do it right here. They'll take that decimal point and move it 2 spots to the left. So that way they don't have to rewrite all the work. And that's okay too. So whatever you're comfortable with. So our final result is going to be 0.1 times make sure that looks like a multiplication symbol there, 0.005. Now this one we actually, so there's our equation, but this one's actually going to be a pretty easy one to solve, right? It's already set up. So if I wanted to actually get the answer, I'm getting on my calculator here. I have 0.1 times 0.005. And I have, all right, so let me show you what my calculator says actually. This is a good example. So here it is, 0.1 times 0.005. Now, calculators are different, but a lot of calculators will do this, as they don't really like to write a lot of decimal places. So what a calculator will do is they'll give you a little symbol. Sometimes it's an E, like it is on my calculator. Sometimes it's a 10, but you'll have a little negative sign and then a number next to it. So I'm gonna write this down so we can all see it a little better. It says 5E -4. So again, sometimes you'll see an E, sometimes you'll see a 10. It just depends on your calculator. It means the same thing. So what it's telling you here is your decimal places. So that -4 that negative means to move the decimal point to the left. And in this case, it's going to be 4 spots. So it's just a way for your calculator to write long decimal points. So here I would take that 5. The 5 is really the answer part. I take my decimal point, which is on the right, and I move 1, 2, 3, 4 spots to the left. And I'm going to fill in any gaps with zeros. So my answer is 0.0005. And then you can put that leading 0 there to represent that whole number part. Notice it's not the same answer, right? So there is an extra 0 here. And our final result then, so I'm just kind of actually solving this because why not? We have 0.0005. So I have 5 10 thousandths for my final answer. Okay, so just watch out for these. You see these a lot on the calculator. If there is no negative sign, so let's say it was 5e to the 4, then you would move the decimal point to the right in that number. So that's the way for your calculator to write really small numbers or really large numbers. And you will see that quite a bit in different classes, and even in our class, sometimes it'll come up. All right, let's do one more of these. So I think this is D. %40 of what number is 20? So again, that of is my multiplication there, that is my equals. These are the most basic of percent problems, if I'm being honest, right? So they're pretty straightforward. My question is my X. And I am going to change that percent over. So I'm going to just use that shortcut here. I'm taking 1/100th of this. So I end up moving it 2 spots to the left. So I have 0.40 times x, which is 20. Or if you want, you can shorten this to 0.4x equals 20. Okay, so just a few examples on how to set up these most basic of percent problems. So in the easiest percent problems, you're really using those keywords like is and of, and then whatever you're trying to find is your variable. And again, I'm using x here, but it really doesn't matter which variable you use. One thing to note in all these cases is that there's sort of always 3 parts to a basic percent problem. You have a percent in there somewhere, and then you have a number and one unknown. Sometimes your unknown is also your percent, right? Because we did see this before. So in the first example, let me go back a couple pages. Our unknown was our percent. So you had 2 numbers, and then your unknown was the percent, but there's sort of always 3 parts to it, right? So a percent and then 2 other numbers. And these parts actually have specific words that we tend to use. So I'm going to give you the equation here, basic equation. And that is basically that the percent times some base amount, some base equals the amount or the answer. Now, there are a couple other words here too. So this word amount, you can also think of as typically, although not always, but usually the part as well. Or we also use the term portion. So you may hear that. A lot of times if you're watching videos on percent, they use the terms base and portion instead. So you may hear those words here. The base you can usually also think about as your whole or your total or your original value, your starting point too. And then of course your percent is your percent, right? So that would be that original percent that you have. So there are 3 main parts. Now they don't always have to be in this order. So in the example above, they are perfectly in this order, right? So here's that percent. Here is the base, and here is the amount. Okay, so what I want you to notice is that the percent is always multiplied by the base. And that base is that whole, that total, that original. It's that starting point value there. So when you're trying to set up more application problems, you really want to think about that base value being that whole, that total, that original. And then the amount or like the answer part is really like the part or the portion you're trying to find. And then the other examples here, again, they may not be in that exact ordering, but that's okay. So here, your amount was on the left, and then you have your percent and your base. So again, the percent and the base are the ones that are always multiplied together. Here, you had your amount on the left, and then you have your percent in your base. And then here you have your amount. And then we had our base and our percent. So the order was changed here, right? This was our percent. Okay. But you should notice in all cases, the percent and the base are the two that get multiplied together, and then they're equal to the amount. And this is really going to help you, particularly when we get to applications, when the keywords are not as clear anymore. It gets a little bit more complicated. All right, so let's actually solve some examples now. And instead of just translating again, we're going to do the full solving process. But it's still going to start with translating. So I'm going to go ahead and take out my colors here. And I'm going to say, there's my is, there's my equals. My of is my multiplication. Here is my question. So when I change this over, I see x equals 35% times 60. So just as a little side note here, again, your percent is usually the obvious one. And whatever is being multiplied with, that is the base. Okay, so the base you're going to notice is next to the word of a lot. So you're often going to see that word of connect you with the base because the base is what's being multiplied. And you're often going to see the word is connect you with the amount or the part because they just tend to be next to each other. Okay. All right, so let's go ahead and change this percent over. So it's going to be 0.35 times 60. And now this is a very easy one to solve. I just have to take out my calculator. And when I multiply that 0.35 times 60, I get 21. So 21 is 35% of 60. Now, you do want to get in the habit of checking this. So obviously you could plug the 21 back into your equation, but also think about it logically. So 35, I usually do it by halves, right? 50% would be half. So as a little side note, right? 50% is equal to half of something. So if I had 50% of 60, well, that would be 30, right? Half of 60 is 30. This is less than 50%, so I should expect my answer to be less than 30, and it is. So it seems like a reasonable answer here. All right, let's do some more examples. And again, we're going to solve this completely. 95% of 200 is what number? So of means multiplication, is means equal. Here's my question, what, right? What number? That's my x. So I have 95% times 200 is what number? And I'm going to change this over to my decimal. So I'm going to use 95 hundredths here times 200. And again, this is another easy one to solve because I can just use my calculator. I don't really have major steps to do. And I have 190. So 95% of 200 is 190. And this should make sense. So 95% is almost 100%, which is the whole, right? So again, as a side note here, 100% is equal to the whole amount. So this makes sense. 190 is almost the whole amount of 200. So it looks like it is logical. 14% of what number is 0.7? Notice that as I'm going through this, I'm really not rushing. I'm just taking that extra 10 to 20 seconds and highlighting my keywords and using different colors and rewriting things. It doesn't take that much extra time, and it really does make a difference so that you can be clear in your steps and also follow your notes later on too, right? So if you're doing a homework question or something like that, maybe you're getting the wrong answer and you can't figure out why. Well, if you have your work written down, it's going to be much easier for you to go back to your steps and see if you can find your mistake, or even send it to your instructor, right? And say, here are my steps. Where is my mistake, right? If you don't have those steps down, if you just have an answer, then it's really hard to figure out what's going on. And also by taking good notes and just taking those few extra seconds, you'll be able to study easier too. Because you can, again, look back at your work and say, oh, yeah, that's what I was doing. I remember how to do that now. Whereas if I don't highlight key things like that, then maybe, if I don't do this stuff here, maybe I go back and look at this and I say, like, how on earth did I do that, right? So taking good notes, even when you're just doing homework and things, can be really helpful, because then when you're studying later, or if you're trying to review something and it's been a while, you'll have those steps there for you. So in math, I think you'll usually find that taking a few seconds extra up front, and it's usually only like 10 to 30 seconds extra up front, you're going to save yourself a lot of time later as you go through the coursework, or even as you're solving an existing problem, because you're going to have it set up correctly, right? Or have a better chance of that. So here I have 1400 x equals 0.7. So I'm going to think about solving this equation here. Now, if you think back to decimals, you can either cancel your decimals out here, or you can just solve with the decimals. Now, for me personally, I'm just going to solve with the decimals because we can now use calculators. So it's not going to be that big of a deal. But you can cancel them if you want to. So if you want to cancel out those decimals, you can. So here, I'm just going to do 0.7 divided by 0.14, and I get that answer of 5. If you were solving with canceling, just as a reminder, you would want to move all the decimal points equally, and you do it with the greatest number. So here I have 2, here I have 1. So I'm going to move everything 2 places, and I fill in any zeros. So you'd have 14x equals 70. And now when you're solving and dividing by 14, you're still going to get that same answer of 5. So again, you're welcome to use either strategy here. I kept the decimals because I can use a calculator now, so I just found it easier. So 14% of 5 is 7/10. Let me move this up for you guys. All right, 13 is 6.5% of what number? So again, at this point in the video, I'm just going to go through some examples. So if you're feeling pretty comfortable, you could try pausing the video and doing the examples yourself, seeing if you're getting the same answer. All right, so I see 13 is 6.5% of what number? Now I'm just going to do this off to the side. So 6.5%. The first thing I'm going to do is I'm going to change this into a decimal. Now I know what 1/2 is, but if you forget, you can just take out your calculator and do 1 divided by 2, right? So 1 divided by 2, and you'll see the 0.5 there. And then you can just do 6.5 instead. So this is 6.5. Be careful, it's still a percent. Everyone makes this mistake. It's still a percent. And now I change over into the decimal form, 1, 2 spots to the left. So I'm going to use 0.065 here. Okay, so just be really careful. Make sure you change to a decimal first, and then still move your decimal point 2 spots to the left here. That's something that a lot of students forget to do. Now I can go ahead and solve this. So I'm going to divide both sides by that 65 thousandths. And again, I'm not worrying about the decimal so much because I know I can use my calculator. And I get 200. Now, we don't always get the nicest answers, but that's okay. This one's coming out nice. So 13 is 6.5% of the number 200. Now, does that make sense? Well, 6.5% is pretty small, and 13 is pretty small compared to 200. So again, when I say small, I'm comparing out of 100% being the whole. So this does make sense here. What percent of 15 is 5? Here we go. All right, there's my multiplication. There's my equal sign. What percent? That's my question. So I'm looking for the percent here. So I have x times 15 equals 5. And now this is fine, but I am going to rewrite it, typically write it this way instead. So I'm going to go ahead and solve here. I divide both sides by 15, excuse me. And I have x equals 5 over 15. And if I want to simplify this, I get 1/3. Now, you want to be really careful here. We haven't seen one of these yet. Notice that I'm solving for the percent. So, important note here. When solving for the percent, the answer is always given in the decimal or fraction form. And it just depends on how you solve. So here I use the fraction form to get 1/3, but if I use my calculator, I get 0.333333. So when you're solving for a percent, you actually are getting it in the decimal or fraction form. To change it, the regular percent form, remember, we multiply by 100. And attach a percent sign. So I'm going to take that 1/3. I'm going to multiply it by 100 over 1, which is 100 over 3. I am going to rewrite this because it's kind of a little bit hard to understand. So 3 goes into 10 3 times, which is 9. 3 goes into 10 again 3 times, which is 9. So I have a remainder of 1. So this becomes 33 1/3%. I can also write this as 33.33333. That's going to be repeater percent as well if I need the decimal form, or I could round if I needed to there too. It just depends on how we want to write our final answer. So this is something to really, really, really watch out for, and that is really easy to forget. So make sure you highlight this in your notes. When you are solving for the percent, the answer is always, always, always going to be given to you either in a fraction or decimal form. Make sure you change it over to percent. So it's not 1/3%. That's not my answer. I have to do multiply by 100 first to get it in the correct percent form. And that's easy to forget. So that's kind of tricky. Let's do one more of those. So 78 is what percent of 65? So again, I'm doing another one of those where you find the percent. So I see 78 is what percent of 65? I'm just going to rewrite this with the 65 first because that's what we're used to. And I'm going to solve by dividing both sides by 65 here. Now I can leave the fraction form or I can change to a decimal. I'm going to check out the decimal here because I don't really feel like dividing that out if I'm being honest. And so when I type in 78 divided by 65, I get 1.2. Remember that if you're going to the decimal form, you always put the numerator in your calculator first. So I get 1.2 here. I could also leave it as a fraction, but I figure I did a fraction here, so let's do a decimal here. And this is fine, but now we have to change to percent form, just like we did before. So I'm going to take that 1.2 and multiply it by 100. Now in the decimal form, this is pretty quick because you're just going to move the decimal point 2 spots to the right? So move decimal 2 places right. And what I get is 120. And then I can attach my percent sign. So 78 is 120% of 65. Now, this actually makes sense. We haven't seen a percent example or equation really yet with a percent higher than 100. So remember 100% represents the whole. So make a note, let's do it in green. So 100% is equal to the whole. I just need to change my view. So if the percent is over 100, then the amount is greater than the base. Okay. And that's what's happening here. So the base is with the of, right? The base is what's multiplied with the percent. So that base is 65. So your amount is the 78. So when your percent is over 100, then that amount, that final answer, is going to be bigger than your base instead of smaller. So that's why you have that change here, but that's totally fine. So we actually see these large percents sometimes as well, particularly in applications, particularly in things like retail and the restaurant industry where we're marking items up. So we may be selling items, so you're gonna have to charge a customer more than what you pay for it, right? So you have a markup there. And that happens a lot in retail, the restaurant industry, etc. So we do see these large percents sometimes. All right, well, I hope you enjoyed that video. In the next couple of videos, we're going to actually keep doing more work with percents, but really do some application examples.